Welcome to the ninth session of Unit 2 in Mechanical Measurements. Myself, Ravi Trivalli, Senior Grade Lecturer in the Department of Collegiate and Technical Education. The Unit 2 is about transducers and strain gauges. In that, the session 9 is about mounting of the strain gauges. In the previous sessions, already you have learned about what are strain gauges and their application. So uh, when a body is loaded, so it get deformed or it get strained. The strain gauges are devices used to measure strain or deformation of an object. So the main applications of strain gauges are: the first is to measure the strain at a point on a loaded member. The second one is to act as a strain sensitive transducer element to measure force, pressure, displacement, etc. In many engineering applications, we have to perform stress strain analysis for the design. So, the measurement of strain is very important to get the exact results. To get the accurate results, the strain gauges should be mounted at the right position with a proper orientation on the specimen or on the member where we have to measure the strain. In today's discussion, the topics covered are introduction to the mounting of the strain gauges. Second one is positioning and orientation of the gauges. Next is steps involved in the mounting of the gauges. Coming to the introduction, the strain gauges are mounted on a specimen or on a load cell to measure the strain developed due to various loading conditions. The strain gauges are very delicate and can easily be damaged if they are incorrectly handled during the mounting on the specimen. So the proper procedure is to be followed while mounting the strain gauges on the specimen or load cell. The positioning of strain gauge and orientation of the strain gauge is very important in the strain measurement. So first we should know how the gauges are positioned and how they are oriented for different type of loads. Coming to the positioning and orientation of the strain gauges. So in the figure we can see the first figure, one gauge is mounted longitudinally, the object is loaded longitudinally. So the strain gauge, the arrow mark there shows the direction of the grid lines of the strain gauge. So in the second figure, the two gauges are mounted longitudinally. So more the gauges mounted on the member, we are approaching more towards the accurate results. So the average of the reading of two strain gauges will measure the strain there. In the third figure, four gauges are mounted, two gauges are mounted longitudinally and two transverse. The two transverse gauges can be positioned anywhere on the rotor member, but they should be mounted in transverse direction only. Now let us see how the strain gauge should be mounted for axial loading. In the figure, we can see in the first figure, the arrow mark shows the load is applied axially. So when the load is applied axially, the member or object will be under tension or compression. In such cases, the gauge should be mounted parallel to the axis of the loading. The total deflections, the applied load and stress can be measured in this case. So some of the examples for axial loading are columns, trusses and cables. Next, coming to the bending loading, in the figure we can see in this type the load is exerted perpendicular to the beam. So force FB, in the figure we can see there force FB is acting perpendicular to the cantilever beam. One side of the beam will be in tension and other side is in compression. In such cases, the gauges should be mounted on both sides of the beam. In the figure you can see gauge 1 and gauge 3 are mounted on upper side and gauge 2 and gauge 4 are mounted on the lower side of the beam. One pair will measure the tension and the other pair will measure the compression. Linear and angular deflections, applied load can be measured in this case. Some of the examples for bending loading are cantilever beam, leaf springs, etc. Next we shall see how the strain gauges are mounted for torsional loading. We know that the rotating body will have a torque or a torsion. In this type, the strain is in the axis 45 degree to the axis of the torque and tangent to the rotating member. That is, axis of torque is nothing but the axis around which the body is rotating. So, in, in this case, the gauges should be mounted in the axis 45 degree to the axis of the torque, that is, axis around which the body is rotating. In the figure, we can see the four gauges are mounted: gauge 1, gauge 2, gauge 3, and gauge 4. So, we can see there gauge 1 and gauge 2 are mounted 45 degree to the axis of the torque or the axis around which the member is rotating. Similarly, the gauge 3 and gauge 4 are mounted on other side of the rotating shaft at 45 degree to the axis of the torque. So some of the examples for torsional loading are rotate, uh, rotating shafts or drive shafts and torsion rods. Next for pressure diaphragm, that is diaphragm is nothing but a thin membrane which is used in the measurement of pressure. The strain gauges should be mounted at the rear or back side of the diaphragm. So in the pressure vessel, for the measurement of fluid pressure, when the fluid flows and come in contact with the diaphragm gets displaced by a small amount. So that small amount of displacement is sensed by the strain gauge and it will be calibrated in terms of pressure. So in pressure diaphragm, The gauges should be always mounted at the rear side and it should not be mounted at the front side of the diaphragm. So that is about how the strain gauges are mounted or oriented for different type of loads. After knowing the position or orientation of the strain gauge, next we have to go for mounting of the strain gauge. So there are four main steps involved in mounting of the strain gauge. The first one is surface preparation. Second one is gauge bonding. Third one is lead wire attachment. And the last step is protective coating. Coming to the first step, that is surface preparation. It includes cleaning the surface, upgrading the surface, and marking of layout lines. So, in cleaning the surface, the surface on which the strain gauge is to be mounted is to be cleaned with a solvent. Solvent is nothing but a liquid in which the substances dissolve. The solvents such as the acetone or methyl alcohol is used to remove the grease or oil present on the surface on which the gauge is to be mounted. Next is upgrading the surface. The surface on which the strain gauge is to be mounted after cleaning it is upgraded with fine grit sandpaper. So the abrasion, the main intention of abrasion is to remove the paints, coatings, and if any oxidations are present on the surface, they have to be removed. Next step is marking of layout lines. So where we have to mount the exact position at the exact position, we have to mark a layout by using a rule and hard pencil. The lines are marked at the required position on the surface of the specimen. The lines are usually the layout is drawn in a rectangular shape or square shape. The lines joining the diagonal. So the intersectional point of lines joining the diagonal will be the center of gauging area. After marking out the layout lines, the first procedure, that is surface preparation, is over. Next, coming to the second step in the mounting, that is gauge bonding. So the first step is using a tweezer. Tweezer is nothing but an equipment to pick small objects. Using a tweezer, the gauge is picked from the pack and placed on a clean working area with bonding side of the gauge down. Next, with the masking tape or a cello tape, the strain gauge is transferred to the marked layout area in the gauging area of the specimen carefully. Now the tape is pressed down on gauging area of the specimen carefully so that the gauge is oriented correctly on the desired area. While pressing the tape, we should take care that the gauge is not disoriented at the gauging area, because orientation of the gauge is very important to get the correct results. So next, the one end of the tape is lifted, whereas the other end of the tape is attached to the specimen itself. Only one end of the tape is lifted so that the gauge does not make contact with the specimen, surface of the specimen, and bonding side of the gauge is exposed. Next, the catalyst is applied with a brush on the bonding side of the gauge. The main purpose of applying the catalyst is it will increase the bonding strength of the adhesive. So after applying the catalyst, a small amount of epoxy adhesive or cyanoacrylate is applied under the gauge on the surface of the specimen. Generally, the cyanoacrylate is used as an adhesive because the cyanoacrylate is a strong and a fast acting adhesive. It is also very less toxic in nature. The cyanoacrylate is commercially known as super glue, instant glue, or power glue. The adhesive should not be applied in excess because later it will overflow on the grids of the strain gauge. Next, the lifted end of the tape is gently placed back to the specimen and a steady pressure is applied with a thumb on a tape for a minute. So after 2-3 minutes, the gauge gets bonded to the specimen. So then we have to peel the tape slowly from the specimen. Thus the strain gauge gets bonded to the desired area of the specimen. So after bonding of the gauge, we have to go for the third step, that is lead wire attachment. So we have to attach the lead wires to the terminals of the strain gauge. In turn, these lead wires are attached to the Wheatstone bridge, which measure the resistance of the strain gauge. The first we have to scratch off the dried adhesive, if any present on the terminals of the strain gauge. As I said, in the gauge bonding step, the excess adhesive should not be applied during the application of the adhesive. So if the more adhesive applied, in the third step we have to scratch off it from the terminals of the strain gauge. Then next, the lead wires are soldered with the terminals of the strain gauge by soldering. Then after soldering, the solder joints are cleaned with the rosin solvent. The rosin solvent removes the residues of the flux. The residues of the flux after soldering should be completely removed, because otherwise that residues will degrade the wire coatings, and also they may, due to the flux, there may be corrosion of the lead wires and terminals of the strain gauge. After attaching the lead wire, we have to go for final step, that is protective coating. So in the protective coating, we have to protect the terminals of the strain gauge and solder joint from water, mechanical, environmental, and with the unwanted electrical signals. So the first one is waterproofing. A polyurethane coating is applied to strain gauge and solder joints to avoid entry of water into the strain gauge, because entry of water may lead shorting of the sensors. So next is mechanical protection. To avoid the damage of the strain gauge, the gauge is covered with butyl rubber. Butyl rubber is a synthetic rubber. It is a copolymer of isobutylene and isoprene. It is not like a common rubber. It does not get damaged easily. It is also chemically inert. That is, it does not react with any chemicals. So butyl rubber is also impermeable to gases. That is, it does not allow any gas to enter inside. Next is electrical shielding. That is, we have to cover the strain gauge and lead wires with the aluminum tape. The intention of electrical shielding is to protect the signals of the strain gauge from the unwanted radio signals or electromagnetic waves. These electromagnetic waves may interfere with the strain gauge signals and they may affect the reading. So the last one is environmental protection. The whole strain gauge is applied with a thin layer of epoxy over the gauge. The intention of applying the epoxy is to protect the strain gauge from the dirt or any moisture present in the environment. So that is how about the strain gauge and the solder joints are protected with the coating. Now let us watch a short video on how the strain gauge is mounted on the specimen.
Hello everybody, this is David from Omega Engineering. We get a lot of questions on how to apply a strain gauge. So today we're going to prep the surface and apply a strain gauge on a bar of stainless steel. So here's what we'll need. First of all, we will need 220 grit sandpaper, solvent cleaner. Today I'm going to be using acetone, the SG496 or the SG401 adhesive, instant cure, a cotton swab, the Omega KFH pre-wired strain gauge, lint-free industrial cloth. First, we are going to polish the surface using the 220 grit sandpaper. Take the sandpaper go in small tiny circles. Once you have the polished surface, we want to remove any dirt or impurities. Just take the lint-free industrial cloth and wipe it clean. Go unidirectionally from one side to the other, just so you don't smear the dirt on the same surface. Then take the Omega solvent cleaner and apply a few drops on the polished surface and wipe it clean. And go unidirectionally from one end to the other. After that, take the solvent cleaner and prep the surface of the strain gauge just to make sure that we don't have any contaminants or dirt sticking on the strain gauge. Now you can use a cotton swab and wipe the surface of the strain gauge clean. Now I'm going to take a small piece of tape, apply it over the surface of the strain gauge uniformly, just like that. And then apply a few drops of the SG496 adhesive, or you can use any cyanacrylite based adhesive, instant cure, on the surface where you want to apply the strain gauge. Apply a uniform coat. Now remove the strain gauge from the cover. You might want to mark the surface where you want to apply the strain gauge. Just place it over there. Apply a small amount of pressure so that the adhesive cures instantly. Press and hold it for a few seconds. Let it stay for a few seconds for the adhesive to dry out. And once it is cured completely, remove the tape carefully from one end. There you have it, folks, a strain gauge attached to the surface of a stainless steel bar. We have multiple strain gauges, different strain gauges for different applications to measure different kinds of strain. If you need help choosing a strain gauge for your application, feel free to give us.
So that was a small video on how the strain gauge is mounted on a specimen. Coming to the summary of today's session. So in mounting of strain gauge, the first step is the positioning and orientation of the strain gauge is very important. The final result will depend on how we orient and position the strain gauges. So after knowing the exact position and orientation of the strain gauge, we have to go for the mounting of the gauge. The steps involved in the mounting of the strain gauge are surface preparation, gauge bonding, lead wire attachment, and protective coating. In surface preparation, the first we have to clean the surface where the strain gauge is to be attached. Then abrade the surface with a fine grit sandpaper. Then mark out the layout lines on the desired gauging area. So after that, we have to go for bonding the gauge with a tweezer. Pick up the strain gauge from the pack and place it on a clean working area. Then using masking tape or cello tape, the strain gauge is transferred to the marked layout lines. Then with one end of the tape attached to the specimen, other end of the tape is lifted so that the strain gauges are exposed. At the bonding side of the strain gauge, the catalyst is applied. Then under the side of the strain gauge, a minimal amount of adhesive is applied on the surface of the specimen. Then the lifted end of the tape is again attached to the specimen, and now the steady pressure is applied with the thumb on the tape and left for a minute. After 2-3 minutes, the tape is peeled off from the specimen, and thus the strain gauge is bonded on the strain gauge is bonded to the specimen on the required area. Then after bonding, we have to attach a lead wire to the terminals of the strain gauge by soldering. Then after attaching lead wire, we have to coat. We have to go for protective coating of the strain gauge and the lead wire at the soldered joints. So that is about how the mounting of the strain gauge is done. Thanks for watching this session.